Welcome to this explainer. Whether we're measuring physical objects or analyzing complex data, equivalent ratios are literally your real-world superpower. I know, it sounds like a massive claim, right? But by the end of our time together, you're going to see exactly how true that is. We're going to look at a few real-life stories and see how this one simple math concept helps us make sense of the whole world around us.
So let's dive right in. Is there a single, let's call it a magic factor, that acts as a master key to unlock totally different scenarios? Think about it for a second. Can one single mathematical trick really solve problems about the lengths of physical strings, figure out human ages, and compare stamp collections on a graph?
Well, here's our roadmap for today. Number 1, strings. Number 2, ages. Number 3, graphs. And finally, number 4, our overarching strategy. Let's get to it.
Section 1. Strings. We'll start with something you can actually hold in your hands. Okay, here are the facts. We've got 3 pieces of string, A, B, and C, and they have a length ratio of 2 to 4 to 1. But here is the crucial piece of evidence. String B is exactly 20 centimeters long. Our goal is to figure out the lengths of the other 2 strings. Now, take a look at our core ratio here, 2 to 4 to 1. This basically means string A has 2 equal parts, string C has 1 equal part. But most importantly, string B represents exactly 4 equal parts of the whole. You see, this ratio is the anchor we absolutely need to solve this entire puzzle.
Following our steps, we hit this great aha moment right at step 3. We compare the ratio to what we already know, which is that string B is 4 parts, but in reality, it's 20 centimeters. So to bridge that gap, we just need to find our multiplier. 4 times 5 equals 20. Boom! Our magic factor here is 5.
And honestly, once you know that magic factor is 5, the rest is a total breeze. We simply multiply every single part of our original 2 to 4 to 1 ratio by 5. So string A becomes 10 centimeters and string C becomes 5. Just like that, we unlock those physical lengths using one universal multiplier. Pretty cool, right? Section 2. Ages. Okay, we solved a tangible physical object. Now, let's see how this exact same logic builds into an abstract human element.
Listen carefully to the facts for this next scenario. The ratio of Maliha's age to her son's age is 11 to 3. And we have this concrete piece of info. Maliha is 44 years old. In plain English, this means for every 11 years of Maliha's life, her son's age represents 3 years. So we need to figure out exactly how old her son actually is.
We're relying on those same steps. We're going to hunt for our new magic factor. Maliha's 11 parts correspond to 44 actual years, and 44 divided by 11 gives us 4. When we apply that to her son's 3 parts, so 3 times 4, it perfectly unlocks his age at 12 years old. It's literally the exact same logic, functioning flawlessly on a totally different real-life story. Moving on to Section 3, Graphs. Let's escalate the difficulty just a bit and step into data literacy.
Before we try solving anything here, the absolute crucial first step is to read the labels carefully on both axes. We really need to pinpoint exactly how many stamps each student has collected. You know the golden rule of data, right? Never guess the values. Always read them directly and exactly from the bar graph.
So, once we've carefully read that graph, we pull that visual data into some nice, neat rows. We confirm student A has 20 stamps and student B has 30. Honestly, writing these numbers out first gives us a really solid, factual foundation to compare their collections without making mistakes.
Okay, now we form our initial ratio by writing the first quantity to the second. That gives us 20 to 30. But this is where step 4 introduces a really vital new tool to our math toolkit, simplifying our answer. Getting to the simplest form is just dividing both numbers by their greatest common factor. For 20 and 30, that factor is obviously 10. By dividing both by 10, we prove that these massive stamp collections boil down to a beautifully simple 2 to 3 ratio. You should always strive to give your answer in this simplified form. It is for sure the gold standard for every single graph ratio question you're ever going to encounter.
Finally, Section 4, Strategy. Now that we've successfully conquered physical objects, human ages, and visual data, let's summarize the whole blueprint. This 4-step master strategy is essentially your universal translation tool. Step 1, read the ratio carefully. Step 2, find that multiplication or division factor. That's your magic key. Step 3, apply that exact operation to every single part of the ratio.
And step 4, simplify if you need to. I promise, regular practice with these exact steps guarantees that solving ratio questions becomes quick, easy, and completely anxiety-free. So,
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.